In straight lines chapter, in this video, we are discussing parametric equations of a straight line. When we observe from last 20-25 years, if at all there is a question from straight lines chapter, 60% of the times it is just application of parametric form of the straight line. Therefore, this method or this technique is very important. So this we call it JE technique 5. So to understand this parametric equation, there are some steps first. From the basic steps we will start with. So that is, you take x-axis, take y-axis, somewhere point is there in the plane. For conveniency purpose, I am taking in the first quadrant. It need not be there in the first quadrant. It can be there anywhere in the plane. This same logic, same idea will work there also. Suppose from that point perpendicular is drawn to x-axis, its distance is alpha, onto y-axis that distance is beta, then the coordinates of that point are alpha comma beta. Now from this point alpha comma beta in the plane, if we move towards right, towards left, up or down, how the coordinates will change, we want to learn in this step 1, right? For example, from that point alpha comma beta, suppose we want to move towards right a distance, small a distance, we want to move towards right. So towards right, horizontally when we are moving, then y coordinate will not change, only x coordinate will change. For the x coordinate, a will be added. It will become alpha plus a comma beta. For moving towards left with the same a distance, so from x coordinate, a will be subtracted. It is alpha minus a comma beta. For moving towards up, now for up and down, x coordinate will not change, y coordinate will be changed. So when it is going up, for y coordinate, a will be added. That is q alpha comma beta plus a. Then for going down, so it is again no change in the x coordinate, but for the y coordinate, a will be subtracted. Then similarly, when we are moving towards right and up, for the right side x coordinate will be added, for up y coordinate will be added. Therefore, then the point reaches, that is a alpha plus a comma beta plus a. For moving towards right and down, for right a is added for the x coordinate, for down a is subtracted from the y coordinate. That point is d alpha plus a comma beta minus a. For moving towards left and up, so it is from x coordinate a is subtracted, from y coordinate a is added. For moving towards left and down, from alpha beta, it is coordinates are alpha minus a comma beta minus a. So here horizontal moving, vertical moving. So this is exactly we have seen in this step 1. Now we will go to the step 2. In the step 2, we are not moving horizontally or vertically. We are moving along a line which makes angle theta with x-axis. Neither horizontal nor vertical, with some slope. In some direction, we are moving from the point, from the given point. Then how its coordinates will change, that is what we will see in this step 2. So for that x-axis, y-axis, like this you take it. Suppose my point is px1 comma y1. From that point towards that line which makes angle theta with x-axis, along that line point P is moving. suppose that the point where it is supposed to be moved along that line up, which is at the distance of r units. Similarly, in the down along that line at the distance of r units in r units, then how the coordinates will change, that is what we want to see in this step 2. You imagine one horizontal line through P, vertical line through P. Then you complete the triangles like this. Then you write the observe the angles, vertically opposite angle, alternate angles, you observe them. So according to that angles, you calculate the lengths of different components. This component is r cos theta. Similarly, this component is r sin theta, right? Therefore, this r cos theta and r sin theta, so r cos theta is moving towards right, r sin theta is moving towards up. Therefore, according to step 1, the coordinates of the point A will be x1 plus r cos theta, y1 plus r sin theta. It is from step 1. Then similarly, to come down, so this component is again r cos theta, and this component is r sin theta. So this r cos theta moving left, r sin theta moving down. Then according to the formula of the step 1, again coordinates of B are x1 minus r cos theta, y1 minus r sin theta. These are the coordinates of the points A and B. So therefore, the observations are that from the point x1, y1 along the straight line whose slope is tan theta, the points which are at the distance of r units from P are x1 plus r cos theta, y1 plus r sin theta. Another one is x1 minus r cos theta and y1 minus r sin theta. Right? Now you see the second point, these equations, the parametric equations of the straight line passing through x1, y1 with slope tan theta are nothing but that generalizing that as theta is constant, because that the direction is constant. In the fixed direction we are moving from point P, that is the direction is constant, means slope is constant, means theta is constant. Now only that distance r is moving. As the keep on r is moving, the point A will be moving. Therefore, x1 plus r cos theta is a variable. It is denoted by x. As r is changing, then x is changing. So x1 plus r cos theta and y is equal to y1 plus r sin theta. As r is the parameter, these two equations together are the parametric equations of the straight line, which will pass through the x1, y1 with slope tan theta. Then the third point is for the same parametric equations of the straight line, other way when you adjust it, other form you adjust it, x minus x1 by cos theta is equal to y minus y1 by sin theta is equal to r. As r is the parameter, this is called symmetric form of the straight line passing through the x1, y1 with slope tan theta. This is exactly the step 2. That is, if not neither horizontal movement nor vertical movement, so if we are moving with some angle, in that angle these are this is the methods to calculate its corresponding points, right? And these formulas will work even for horizontal vertical moving also. For horizontal movement, theta is 0, it coincides with step 1. For vertical movement, theta is pi by 2. Again, whatever the points you are getting, they will coincide with step 1, right? So this is exactly the parametric form of the straight line. By making use of this, first let us solve a simple problem. The problem is that find the slope of a straight line which is passing through the point A2, 1 and meets some other line at a distance of 3√2 units from point A. Here, point A2, 1 is given. Through that one line is passing. intersecting some other point at 3 root 2 distance, right? Then what will be the slope of that line? The diagram is like this. This is the straight line exactly for which we are supposed to calculate its slope. It is passing through the point A, 2, 1, and you assume its slope is tan theta. Now this line meets this line x plus y is equal to 9 at some point. That point is P. And the distance from A to P is 3 root 2, which is given there. Distance from A to P, 3 root 2, which is given there. Once it is the distance from A to P is 3 root 2 and its slope is tan theta, according to our step 2, the coordinates of P are 2 plus 3 root 2 cos theta, x1 plus r cos theta, y1 plus r sin theta. Here the x1 and y1 are 2 and 1. R is 3 root 2 cos theta and sin theta as it is. Now you observe this point P, we have evaluated the point coordinates which are at the distance of 3 root 2 units from point A. But you observe that that point is also there on the line x plus y is equal to 9. Means in this line equation, when we substitute these coordinates, 2 plus 3 root 2 cos theta, 1 plus 3 root 2 sin theta, that equation must be satisfied. Substituted that, then from that 2 and 1, 3 root 2, everything is thrown other side. Then sin theta plus cos theta got it to be root 2. Squaring both sides, 1 plus sin 2 theta is 2. Then from that theta is equal to pi by 4 will come. But slope is asking. Slope is nothing but the tan theta. That slope is nothing but the 1. So our question is, what is the slope of that straight line? The answer is that the slope of that straight line is 1. This is the conclusion. This is one simple problem, simple observation, right? In the diagram itself, the problem can be solved once you know the parametric form. Now, with this parametric form application only, little higher level, actually this is a previous IIT JEE problem. So this problem also, let us solve it in the diagram only. Very easily it can be solved if we use the parametric form. So the equations of the diagonals of a rectangle are y plus 8x minus 17 is equal to 0 and y minus 8x plus 7 is equal to 0. Diagonals of a rectangle are given. Means diagonal equations are given. If the area of the rectangle is 8 square units, then what are the equations of sides of the rectangle? What are the equations of sides of the rectangle? Here, in a rectangle, diagonal equations are given. Area of the rectangle is also given. We have to find out what are the equations of the sides. So idea is that if we calculate the 4 vertices, then automatically sides will come. Suppose one diagonal is this one, you assume y minus 8x plus 7 is equal to 0. And the second diagonal is y minus 8x, y plus 8x minus 17 is equal to 0. In a rectangle, the point of intersection of diagonals is nothing but its center. By solving the two equations, we will get the center as 3 by 2, 5. Now, for this diagonal, y minus 8x plus 7 is equal to 0. Its slope is tan theta, which is 8. Then its corresponding sin theta, 8 by root 65. And corresponding cos theta, 1 by root 65 for this straight line. Then on this straight line, from the center, the point at the distance of r units from the center, right? The point coordinates according to the step 2 are x1 plus minus r cos theta, y1 plus minus r sin theta. So by making use of that, the coordinates of point A, which is at the distance of r units from point P, right, is 3 by 2 plus r cos theta. Here the cos theta is 1 by root 65 and 5 plus r sin theta. Again sin theta is 8 by root 65. So A coordinates are that is 3 by 2 plus r by root 65, 5 plus 8r by root 65. Similarly, in the other side of the point P, with the same distance r, with the same sine theta and cos theta, because it is there on the same straight line. So C coordinates will be 3 by 2 minus r cos theta, 5 minus r sine theta. And then on the other diagonal, tan theta is equal to minus 8. It's correspondingly sine theta is minus 8 by root 65. Cos theta is 1 by root 65. You can interchange this sign also. You can put the minus sign for cos, plus sign for sine also, nothing wrong. It gives you the same thing. Now along that line, from the center, the point at the distance of r units, that is the point B, is 3 by 2 minus r cos theta, 5 plus r sine theta. That is 3 by 2 minus r cos theta, 5 minus r sine theta. That sine theta cos theta, when you substitute, you will get the coordinates of B. Then similarly, at the distance of r units in the other side of that diagonal, D coordinates are 3 by 2 plus r cos theta, 5 minus r sine theta. That is 4 vertices are formed like this. When we join them, the rectangle is formed like this. Now we got the coordinates of the vertices of that rectangle in terms of only one unknown, that is small r. The coordinates of the vertices of the rectangle in terms of only one unknown, that is r. Now the additional information is given that the area of the rectangle is 8 square units. Now let us calculate its area in terms of small r. When we calculate the area of the rectangle, it is the length into breadth. Here the length is nothing but the AD. You observe the points A and D. Its x coordinates are the same. Once x coordinates are the same, then the difference between the y coordinates is exactly the distance between A and B. That is exactly the length. Therefore, AD length is 16r by root 65. And you observe the points A and B, their y coordinates are the same. Once y coordinates are the same, then the distance between its, that is the difference between its x coordinates is exactly the distance AB, that is AB length is 2r by root 65. So this length into breadth, that is AD into AB, is area of the rectangle, that is 32r square by 65. But this is given as the 8 in the problem. So from this, r value is root 65 by 2. This r value, you substitute in the vertices, vertex A, vertex B, vertex C, vertex D. You substitute these r values, then you will get those points as A is 2,9, B is 2,1, C is 1,1, and D is 1,9. You got 4 vertices of the rectangle. Once we got the vertices, then sides can be calculated very easily. You observe the vertices A and B. In the vertices A and B, x coordinate is the same. Therefore, AB equation is x is equal to 2. Vertices B and C, in that one y coordinates are same. Therefore, BC equation is y is equal to 1. Vertices C and D, its x coordinate is the same. Its equation is x is equal to 1. When we observe points A and D, its y coordinate is the same. Therefore, AD equation is y is equal to 9. So this is one of the nice applications of parametric form of the straight line. Like this, there are so many problems on the parametric form. In my next videos, that problems will come and solutions also will come. You just wait for those videos, right? So I wish you all the best.